Hi Algebra, this is part 2 of domain and range, and we're going to be looking at some examples this time with graphs and determining domain and range. Here we go. First, we are skipping ahead in this lesson to the activity called back to the bouncing ball, and we're going to have a graph here of a tennis ball that was dropped and it was bounced, and we're tracking its height over time. Number 1, h of 0, remember this 0 is your input or your x value, so at 0 seconds, it is at 6 feet in height. Number 2 is asking you to solve for h of x equals 0. That means for what x values is the output 0? Well, everywhere that the ball hits the ground, its output, its height is 0. So at 0.5, at 1.5, at 2.25, at 3, and just a little bit over 3.75, so I put 3.8. Number 3 is now looking at the domain of the function. Those are all of the possible inputs or all of the possible x values. Looking at our graph, we are starting at 0 seconds and we're going until the ball stops. So we don't really know on this graph when it stops. So we can just say from 0 seconds until the ball stops. The range of the function is all of the possible y values, and we can see on the graph that it goes from anywhere from 6 feet to 0 feet. We cannot go into the negatives, so we're going to write this using our math notation. We're going to say that y is going to be between 0 and 6, and so it's going to look like this, saying that 0 is less than or equal to y, which is less than or equal to 6. This is the fancy way of saying that y is between 0 and 6. This includes all the fractions and decimals, but that's okay because we can have fractions and decimals in our height. There are 2 examples in your lesson summary that are good graphs to look at, so find these 2 graphs. We've seen these graphs before, but now we're going to be looking at identifying the domain and range. Domain, again, is all the possible x values, so in our first graph with the number of bagels, we can see that the possible x values have to be whole numbers because we can only buy whole number of bagels, and it looks like it goes from 0 to 13. The range with our bagels, well, prices can be decimals, and they don't have to be whole numbers. So we're looking at anything from 0 up to, it looks like 11, we could say 75. Now you can use the words between 0 and 1175, or we can use more math notation like this, which is showing that y is between 0 and 11.75, including all of the decimals in between. The next graph we're looking at is the bungee jumper graph that we have seen before. And the first thing we're looking at is the domain. That's all of the possible x values. We know that we're starting here at 0 seconds. We can't go into the negatives. And the bungee jumper jumps and is bouncing, 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 and it's going to keep going. We don't know exactly when it ends. So we could say our domain, our possible x values is x is greater than or equal to 0 seconds. And that just means that it has to be a positive number. It can be any of the decimals and fractions in between, and we don't know when it's going to end. The range is all of our possible y values. And we knew from this problem before that we started at 80. It looks like we go down to 10, and that seems to be the lowest value. So we're going to say from 10 to 80, and it's going to include all those decimals in between because it's okay to have partial meters in this problem. When you're describing domain and range, you can use descriptions like we did here, like the whole numbers from 0 to 13, or you can use that more mathy notation saying that your values are going to be between one number and another number, or just like something like this where we're saying that that's positive. So feel free to do words or that mathy notation.